All right, what we have here, guys, is the relation between the solubility of a solute versus the temperature at which it's at. So this is all related to temperature. So like it says at the very top of the screen, solubility of most solids will increase, as the temperature increases, okay? So all these lines that you see on this crazy graph below that are all going in an upwards direction from left to right, those are all going to be solids. They increase their solubility as the temperature increases. Now, let me explain this graph before I get much further. If you guys all look at the x-axis down here, what we have is temperature. We have everything here from freezing, 0 degrees Celsius, all the way up to 100 degrees boiling water. So that's from liquid water all the way to almost gaseous water vapor. We have all the temperatures in between. On the y-axis, what we have is the amount of solute measured in grams per 100 grams of water. 100 grams of water is the same thing as 100 milliliters of water. 100 milliliters of water is not very much. It's a beaker about that big. It's very small. The reason why they use such a small quantity is because really you could extrapolate that to any volume. It doesn't really matter. 100 grams is just very easy to manipulate on a hot plate or to do this experiment. Now, what I'm talking about is this graph. I'm going to go ahead and highlight a specific line for you guys because I want you guys to focus on something real quick. All right, so let's just say I'm going to talk about ammonium chloride, which is this one right here. So what they did is they took 0 degrees Celsius water and they dissolved as much as they possibly could until it became saturated. Now remember, saturated means it has dissolved the maximum. If you add any more, you're going to go beyond that threshold and it will settle to the bottom and you are now oversaturated. So at 0 degrees Celsius for ammonium chloride, you're able to dissolve just a little bit under 30 grams, right? Then they went and heated that up to 10 degrees Celsius. They did the same thing. They added a little bit more ammonium chloride, and it appears they were able to dissolve about 33, maybe 34 grams. They keep doing this for every single temperature, all the way up to 100 degrees, which is boiling, and they were able to get about 74 to 75 grams. Now, so that's where they get the curve that you're looking at for the ammonium chloride. They then did the same thing for the other 8 compounds, because there's 9 compounds on here. And so what we get is a crazy looking graph with 9 different lines, but all of them represent the saturation point for that compound in water at that specific temperature. Now you'll notice, again, potassium nitrate has a very different curve from sodium chloride, and then table salt sodium chloride, potassium nitrate and ammonium chloride, but sodium chloride, again, is very flat. There's very little change in the solubility of sodium chloride as we increase temperature. So these are all quite different. Again, like I alluded to in the previous video, you'll notice that all of them are going up. There is 2 that are going down, which is ammonia and cesium. Sorry, that's cerium sulfate. I've been saying cesium all day. Cerium sulfate. They are both going down, and that is because they are both gases. The solubility of gases is the opposite. So as you have a hot liquid, the solubility of gases actually decreases. Whereas if you have a hot solid or you try to dissolve more solid into a hot solution, you will be able to get more dissolved. So I'll touch on that again here in a moment. But that's basically what we're talking about. So anything, again, talking about ammonium chloride, anything on that line represents saturation, which is the maximum threshold that you can dissolve. Anything up here would be supersaturated or oversaturated, and anything down here would be unsaturated because we would be able to add more. Again, this right here is saturation. All right, now that we understand the concept, let's go ahead and start with number 1. It says, what is the solubility of a saturated solution of potassium nitrate at 10 degrees? All right, what I need to do is find my 10 degrees. It's right here. I'm going to go up until I find my KNO3, and I've already passed it. Oops. So my KNO3, which is right there. Now, again, this is really easy to make this mistake because notice in this corner right here, these lines get really pretty crazy. So I already made the mistake because this line dips so low, you have to be very careful to look at the right line. The most common mistake students make is they find the wrong line, kind of like I just did. So I'm going to go over from that intercept over to the y-axis, and it appears that at 10 degrees of potassium nitrate, I would be able to dissolve approximately 23 to 24 grams. Okay, we could differ on 23, 24, but it's somewhere in that ballpark, right? I think we could agree on that. So that's the amount of solubility of a saturated solution. Saturated again means the line, potassium nitrate at 10 degrees. When they say what is the solubility, they basically just mean how much can be dissolved. That's all they're asking. It just sounds kind of fancy and complicated, but it's really not. Number two, it says which compound is saturated if 80 grams are dissolved in 100 grams of water at 50 degrees Celsius. Now, real quick, 100 grams of water, that is referring to this. As long as those match, then we're good. We don't need to worry about them. You'll see later when these don't match, and that becomes a problem. But for now, I could ignore the 100 grams of water because that is the same as this. So that's good. All right, so again, what compound is saturated if I have 80 grams is dissolved at 50 degrees? So I'm going to see where those match and where they meet. And which one is saturated right here? That, of course, would be KNO3. KNO3 is going to be saturated at that temperature if I have 80 grams dissolved. Now, again, if I was talking about this curve, then this point would be unsaturated because this point would be underneath this curve. I'm just saying that just for example. That doesn't really relate to number two, but I'm just taking it one step further for you to understand. Number three, it says which two compounds have the same solubility at 57 degrees? 57 degrees is approximately right here. I'm going to go up, and what I find is there's an intercept right there. Because they intercept at that point, that means their solubility is the same. So it is definitely going to be this curve, KClO3, and this curve, NH3. So NH3, ammonia, which is a gas, and potassium chlorate, which is a solid. Those have the exact same solubility at roughly 57 degrees, which they are not asking us, but if they did, it would be approximately 24 grams. All right. I just realized I need to, let's see if we could use this graph. This is going to be a little tough. I might have to scroll a little bit. All right, number four, it says, if I have a solution at 60 degrees Celsius containing 35 grams of ammonium chloride, is the solution unsaturated, saturated, or supersaturated? Okay, that's interesting. So my solution again is at 60 degrees, and I have 35 grams. So I'm going to see where those two meet, which is right there. So there's my point. Again, we're talking about ammonium chloride. Ammonium chloride is this line right here. So this line that I just drew represents saturation. My point given to me in the question is right here. My point is below the curve. We are under the curve, which means we are unsaturated. Now, if they wanted to take this one step further, and sometimes they do this, they might ask you, how many more grams could we add to make it a saturated solution? So we already know that we have 35 grams. If I was to figure out how much I should be able to dissolve, it is approximately 56 grams, right? Roughly 55 or so. So again, I should be able to add, if this is 35 and this is roughly 55, then I should be able to add about 20 more grams on top of this to get it to be saturated. Now, again, they did not ask that. I am just letting you know that's a potential question that they could certainly ask. But just to repeat for number four, we have 60 degrees Celsius. We have 35 grams. I found that they met at this point right here, my little smudge. My big dot is below the curve. Therefore, we are unsaturated. Again, I then took it one step further and I just answered how much more could we add, which basically is, again, the difference between here and here, which is approximately 20 grams. All right, so the next question. Number five, it says, both NH3 and cerium sulfate are sloping downwards. What can we assume about them? Again, I already told you guys that. Again, they are gases. The solubility of gases are the opposite of solids. Number six, At what temperature would a solution containing 60 grams of potassium nitrate in 50 grams of water be saturated? All right, so now we have a problem. This 50 grams of water is going to be an issue because remember, all of this is for 100 grams of water and those do not match. Therefore, we're going to have to do something to make them work. So the graph, we're not able to change it because it's our reference. It is our provided graph. Obviously, we cannot tweak that. So we're going to have to do something with the question to make it match the graph. So if I needed to make it into 100 grams of water, I would take this and multiply it by 2. But if I change and double the water, I would need to double my amount of solute. So I don't have 40 grams of potassium nitrate. I actually have 80 grams of potassium nitrate in 100 grams of water. Now we could use the graph. So I'm going to go to 80 grams, not 40, but 80. I'm going to go over to KNO3 right there, and then find out at what temperature that would dissolve, and it is 50 degrees Celsius. So just to talk through that one more time, because the question was half the volume of water, we had to double that number to get it to match the graph. If we double the amount of solvent, water, then we need to also double the amount of solute, the potassium nitrate. If we didn't double the 40 grams into 80 grams, then you're fundamentally changing the concentration. You are diluting it by 2, which again is not the same solution as, because again, 40 grams in 50 grams of water is the same concentration as 80 grams of solute in 100 grams of water. All we did was doubled everything. That's all. Okay, the next question, again, this is going to be a little hard because I have to scroll. It says, how many grams will crystallize from a saturated solution of KCl in 200 grams of water? So again, that's a clue. Notice I put it in bold to be nice. 200 grams of water at 100 degrees Celsius that is then cooled down to 20. All right, so for this one, there's not anything like number 6 where we could change the numbers and double everything or have everything, because we don't have any numbers for number 7. All we have are temperatures. So what we're going to do is we're going to use the graph as it is. We're going to find 100 degrees. We're going to go up to KCl. So KCl is right here. And that is approximately, I would say, 56 grams, okay, ish. And then it's going to be cooled all the way down to 20 degrees. So 20 degrees, I'm going to go up to the same KCl curve. And I'm going to be very careful. I'm so careful, I made a squiggly line to go to the correct line, because again, it's really easy to make that mistake with all those crazy lines there. I'm just trying to match it to this one right here. And that is approximately 33 grams, give or take. Okay, so when it's at 100 degrees, I could get 56 grams. When it's at 20 degrees, I can only get 33 grams. So what I need to do is find the difference, which means subtract. So if I have 100 grams of water and I have these temperatures of saturated potassium chlorate, 23 grams should crystallize and fall out of solution to the bottom. Okay, but we want twice that volume, twice the volume of the problem. So I'm going to take my 23 grams and I'm going to double that to give me twice the volume of my crystallized insoluble solid. So my answer would be 46 grams would crystallize as I cooled my saturated potassium chloride solution from 100 to 20 degrees Celsius in 200 degrees or 200 grams of water, twice the volume of what the graph tells us, okay? Again, like I said, when the water doesn't match, as long as it's 100 grams, it's really quite simple. But when it's not 100 grams of water, then you have to be a little careful to make sure that you're doing it correctly. All right, guys, last question as far as the graph goes. It says, how much sodium nitrate must be added to make a saturated solution in 50 grams of water at 10 degrees Celsius? Okay, so sodium nitrate at 10 degrees Celsius. So sodium nitrate is this one right here. And again, we're looking for 10 degrees Celsius. I'm going to go up to my curve, squiggles, that's on accident. And it's about, I don't know, what, 80 grams? Sorry, that is really ugly. 80 grams, okay? So if that's the case, going back to my problem, it says how much sodium nitrate would be added to make a saturated solution. Okay, we know that's 80 grams, but in half the water. half the amount of water. So what I'm going to do is I'm going to take my 80 grams that I determined from my graph, which is out of 100 grams of water, and I'm going to divide it by 2. So my answer is approximately 40 grams because, again, they want half the water that is shown in the graph. So, like I said, the graph is not anything complicated. It looks complicated. The easiest mistake is that you look at the wrong line because they cross so much. So you have to be really careful when you're doing that. And again, the other thing you need to be careful with is when the amount of water is not 100 grams. That's when you need to slow down, think it through. Are you going to have to multiply or divide to get it to match? Last but not least, it says, how is the solubility of gases compared to solids? Again, they are the opposite. Again, the solubility of gases increases as it gets hotter. The solubility of gases decreases as you get it hotter. So this is why if you have a soda can or let's say a Coke, then the solubility of the carbon dioxide, the carbonation, is going to be best and most ideal for us when the soda is cold. When the soda is cold, more of the carbon dioxide is dissolved in there. It has more of the fizz, the more of the carbonation that we like. But as that soda warms up, as it sits on your counter, then it's going to warm up and the solubility of the gases is going to decrease, which causes the gases to escape, which causes your drink to become flat. So if you want your soda to be have as much gas as possible, again, you keep it cold. If you want it to go flat, then you warm it up. So again, if you're a fish and you live in the ocean or in a lake, then you typically like the colder parts of the lake, the deeper parts of the lake, because that's where the water is the coldest. And where the water is the coldest, you'll also have more dissolved oxygen. So on number 9, it says, on hot summer days, fishermen find the largest fish in the deepest parts of the lake. Why is that? Because the water is the coldest down there. And if the water is coldest down at the bottom of the lake, there is more dissolved oxygen. The fish will breathe better and be happier down at the bottom of the lake versus up at the top. So in these hot summer Texas summers, when the lakes start warming up and it gets blistering hot outside, the fish aren't so happy here in our lakes because as the lakes warm up, the solubility of the gases decreases, meaning the oxygen starts to escape the water, and the oxygen concentration of the water tends to drop. And the fish don't like that very much. Whereas when it's wet and cold, it's not wet, when it's cold, again, the solubility of the gases is going to increase. All right, guys. So that's basically what we call solubility curves or solubility graph. Again, all the solubility of these particular 9 compounds, again, there are other solubility curves that have other compounds. That is just going to be the one that you're going to see most frequently for whatever reason. Those are the 9 most commonly used. But like I said, you could find a solubility curve for pretty much any compound that will dissolve in water. As always, guys, thank you very much for watching.